Goddard has really played a lead role in the world in moving LiDAR from airborne and ground-based missions into space.
I mean, the future is in the hands of the creative people here and elsewhere in industry that can just take this and run with it. We've revolutionized how we look at our own world, and the future is wide open. Winds, aerosols, trace gases.
I've been spending a lot of time and most of the past decade working on a LiDAR to measure atmospheric CO2, and we've been flying that fairly regularly on aircraft. We've got this remarkable data set that really proves, I think, our approach really works well. There's many other gases that are very important, particularly with global warming, that lasers can help us monitor.
Over all these years, we've developed these different techniques and lasers and detectors and put all those together into a recent system that we've just started working on, the hazard detection LiDAR. Essentially a really precise, really fast LiDAR that helps land safely on a planet. You want to make millions of measurements in a second. You have to process and produce those data in real time.
This technique is giving us better understanding of where we live, where we want to live, where we want to explore in ways that are fundamental. So I look at it as it's a measurement engineering success story, and masterpieces of engineering often lead to masterpieces of science.
With Molar 2 being on MGS being the ones I look back on most, as being absolutely, they really shook me up as well, and I think they shook up the community as well and said, what you could do with a laser altimeter.
And I'm amazed at how much knowledge can be gleaned from this relatively simple measurement, just measuring time of flight.
So you cannot just build just one LiDAR. You need a sustained team who's been building LiDAR for some time, so you can pass on the lessons learned and so forth.
To see that rocket go up with the thing that we had worked on for so long finally become a reality. I had my family with me, many of the other scientists had their family. The reason many of us also bring our family there is because of the sacrifices our families had to make this a reality. Because of the long nights and being away and the amount of effort we had to put in.
There's a lot of special pieces that need to go into it, and a lot of experience that's just built through decades of doing. Across Goddard, they bring in new people to learn through mentorship and learn by doing on these projects.
What I love about NASA, and in particular Goddard, is still this way, but it was really a meritocracy, meaning it didn't matter what school you went to, what degree you had at some level, right? That just got you in the door, but how you progressed through NASA was really based on what you did.
I never suffered from being, I never was not promoted, or I never was told I was doing a bad job or anything like that because I was a woman. Well, I think Goddard has been a fantastic place to work.
When you get to work on something new and exciting, that is privileged. It's a privilege.
Getting good people to work with you, knowing what risks to take, those are key factors in success of all these things.
It's working with the scientists. You're in the same team, you're in the same room, you're in the same meetings, you're down the hall from each other, you're in the same organizations.
Our successes of the past are due to some very simple things. And that is that Goddard is, as a center, a people with an incredible dedication and devotion to their work.